All right, Math 2, we are going to be starting section 4.2 on page 207. So go ahead and get your book opened, and we're going to go through a bunch of pretty important theorems that they have in here. Before we go to the first theorem, let's just backtrack a little bit and go through some terminology. They are going to talk about something called a perpendicular bisector. We've done this before. What a perpendicular bisector is, it not only hits it at 90-degree angles, but it also bisects, which means D is the midpoint. So if this were the perpendicular bisector, you can automatically put 90-degree angles in, and you can mark the two segments as being congruent. But what this is saying is, if I wanted to go ahead and connect the endpoints of that segment to anything along the perpendicular bisector, you now have formed two triangles. And these two triangles have to be congruent because you have the reflexive side. So by side, angle, side, these two triangles are congruent. Well, if they are congruent, then doesn't it make side AC congruent to side BC, which now makes this one ginormous isosceles triangle. All right, so a lot goes on just because that's a perpendicular bisector. It's important to know, and we'll get to the theorem in a minute, that if the perpendicular bisector is here, the distance from the endpoint to a point on the bisector is the same. And they talk about this word equidistant, and equidistant means two distances or two objects that are the same distance. All right, so over on page 208, here is our first theorem. What it says is if you have an isosceles triangle and you are going to come over here and draw in a, up here at the top. If you have a perpendicular bisector drawn, just like it was in the previous picture, that the distance from the endpoint to any point on that bisector will be congruent. So these two distances will be the same. So if I make a, another point right here, and let's call this F, the distance from A to F and the distance from B to F have to be the same. Coming down here, you have the converse of the one we just talked about. If you have an isosceles triangle and you draw in a perpendicular bisector, you know it goes through the midpoint and things like that. You know it's going to be bisecting in that case. All right, so let's come down here and take a look at what we're going to have on the first example under the got it. First thing you notice, these are congruent, so that's the midpoint. Here is the perpendicular, so you know that this is the perpendicular bisector. So these two triangles have to be congruent by side, angle, side, which forces these to be the same because of CP/CTC and the theorem that says that. So you're going to solve for n. In order to solve for n, you're going to write 3n minus 1. That is, this side has to be congruent to that side, which is 5n minus 7, and you'll just solve. So you get 2n, add your 7 over, gives you 6, so n is equal to 3. But that's not the question. The question is, what is the distance from Q to R? So you're going to go plug 3 in here. It gives you 15. 15 minus 7 is 8. And if you stick 3 in here, you get 3 times 3 is 9. 3 minus 1. Or 9 minus 1 is also 8, so you can check your answer. But the answer to this one is 8. The distance from Q to R is 8. All right, going down to the next problem. Again, you see that these are congruent, which means B is the midpoint. I see my 90-degree angle here, which means this is the perpendicular bisector, so these have to be the same. And you'll just set up a problem and say 9x minus 18 is equal to 3x. And then once you get your x, you can find your distance from J to M, which is the second part of the problem. The first part says, what is the relationship of MB to JK? Well, MB to JK, they're perpendicular. That's the relationship. So you would say they are perpendicular. All right, let's go down over on page 209. I'm going to go to the problem here that has the city map. All right, so you have the map of part of Manhattan, and the question is St. Vincent's Hospital, which is right here, is it equidistant from the kid nursery and the legacy school? So what you're going to do is find the kid nursery and the legacy school. And you're going to connect those 2 points. So they would be like the endpoints of a segment. All right, so we have the endpoints of the segment. Now, in order to find if it's equidistant from those 2 points, it has to lie on the perpendicular bisector. So looking at this, I'm going to say the perpendicular bisector would probably be like 6th Avenue right here. It would be pretty close to its perpendicular bisector. Or even over maybe just a hair. Anyway, you're going to draw on this perpendicular bisector, so cutting it in half. And the question is, does St. Vincent's Hospital lie along that perpendicular bisector? And the question is no. So when it says, how do you know it's not? That's the question. So is it equidistant from the nursery school and the legacy school? No, it is not. How do you know? Because it does not lie on the perpendicular bisector. All right. Let's turn over to page 211. And we're going to talk about something pretty similar to that, except for we're going to go over to angle bisectors instead of segment bisectors. So same idea. You're going to have an angle bisector. It's going to cut it in half because it's marked, and you're going to pick a point along it. So D can be anywhere on it. And you're going to be drawing down a bisector and, a perpendicular line and a perpendicular line. These two have to be the same length in order for it to be on the on the bisector of that angle. So you can look through the next two theorems, which kind of state that. All right, over on page 211, let's go through our examples. So up here, the first thing you're going to look for is it being bisected? Yes, it is. Are these 90-degree angles? Yep. And if that is the case, then you know that this segment and this segment have to be congruent. So you would write the equation 6x plus 3 has to be the same length as 4x plus 9, and you would solve that. So subtract your 4x, subtract your 3, divide, you get x to be 3. But the question is up here, what is the length from F to B? So now you'll take your 3, plug it back in here, and you take 6 times 3 plus 3. So you get 18 plus 3, which is 21, and I'm guessing the next one comes out to be 21 as well. All right, going down to the first problem on the practice, it wants you to find the angle measurements. So let's come over here to the picture. What you should notice is that these lengths are both the same, so that has a length of 27. Do they hit at 90-degree angles? Yes. And if that is the case, then I know these two angles have to be the same. So you would write 6y has to equal 4y. Oops, that's a really bad y. 4y plus 18, you're going to subtract your 4y, so you get 2y equals 18, which means y is equal to 9. But again, that wasn't the question. We wanted to know what the two angles were. So HKHL is this one, so you'll take 6 times 9, so since it's 6y. So this has a measure of 54 degrees, and then we want FHL, so FHL, and we've done our math right, it should come out to be the same, so take 4 times 9 is 36, and 36 plus 18 is 54, so they both equal 54. All right, coming down to the last example here, the first thing I'm going to notice is that the angle was bisected, and then I'm going to notice that we have 90-degree angles, which again forces these two things to be equal. So you're going to do the same thing, set them equal to each other. So x plus 5 has to equal 2x minus 7. Subtract your x, add the 7, so you get x to be 12. So x was 12. Now to find the length from j to k and j to m, knowing they should be the same, take 12, plug it in here. 12 plus 5 is 17. So x equals 12. jk, equals 17, and when I plug it in here, we should also get 17. So 2 times 12 is 24, and 24 minus 7 is 17. So J to M is also 17, and there's your answer. All right, let's just go through a few more problems. On the bottom of page 211, we have the lesson check down here. Why don't you go ahead and give this a shot. What it's asking for is like the distance from A to C, B to D, or what's the relationship, things like that. So I don't know. Looking at here, I notice that this is a perpendicular bisector. I don't know. Let's just walk through it and then we'll answer the questions that it really wants. Looking over here at the left side of my finger, you have your perpendicular bisector. Those triangles are congruent. Therefore, the distance from A to D is the same as A to B. All right, so that is 15, and the same thing is going to be true over here to the right side of my finger. You have a big isosceles triangle right there. Because of this 90 degrees, that forces this to be 90. They're all 90, really. So that's 18. What does it want? What is the relationship between AC and DB? It looks to me like they are both perpendicular bisectors of, well, they're just perpendicular. But there's your answers to those. So on the top of the page, it asks you what are the lengths of those. You can go back and look at our picture to get that. Okay, let's look at 16. I'm over on page 213. This is the type of question you might see on a quiz. It says R is on the perpendicular bisector of TZ. So why don't we draw a segment TZ right here? All right, so here's T, here's Z, here's our perpendicular bisector that goes down. And what we know is R is on the perpendicular bisector. So I don't really care where you want to place R. You can place it up here, down here, does not matter. I'm just going to go ahead and put R right here. If R is on the perpendicular bisector, then I know the distance from R to T and R to Z have to be the same. So let's go fill in this blank. Then R is equidistant, that's what I want right here, is equidistant from T and Z, or, and then this is what it wants here, your equal length. So you would say TZ, or I'm sorry, TR is equal to ZR, and that's what it's looking for. All right, your homework is going to be up here on M2 IXL, and it's all over setting things equal to each other, just like the last IXL. Good luck.